Hello everyone, here is a question based on coordination compounds. Number of complexes with the even number of electrons in t2g orbitals is how many? We have 5 different aqua complexes. In 3 cases, the net charge is given as 2 plus. We know that water is a neutral ligand. So therefore, for the metal ion 2, we can put the same charge as the acceleration state, because water is a neutral ligand. And in 2 cases, the charge is given as 3 plus. For these 3 complexes in particular, we need to be little bit careful, because for copper and chromium, we write the electronic configuration slightly differently. Whereas for this one, we have to consider water as a strong field ligand. In general, we consider water as a weak field ligand. But when the oxidation state is 3 plus, for cobalt, we have to consider that one as a strong field ligand. So that is the only exception here. In all other 4 cases, we are going to consider water as a weak field ligand. So let's do this one by one. For Fe, we know that atomic number is 26. So therefore, when it is neutral, the electronic configuration is argon and then 4s2 3d6. However, when it is Fe2 plus, we are going to have only 24 electrons. We need to remove 2 electrons. Therefore, now the electronic configuration is argon and then 3d6. 4s2 is the outer shell with the n value equal to 4. So therefore, those electrons should be removed. Therefore, in the octahedral crystal field, this would split into t2g and Eg. So we have 6 electrons, 1, 2, 3, 4, 5, 6. So t2g 4, Eg 2. We have even number of electrons in total within t2g orbitals. We shouldn't think about these 2 electrons. In total, do we have even number of electrons? That's what we need to consider. So therefore, this one is yes. Let's go to the next one. For cobalt, oxidation state here is 2 plus. We know that atomic number of cobalt is 27, but when it is 2 plus, we are going to have only 25 electrons. Therefore, the electronic configuration is argon and then 3d7. In presence of water ligands, this would split into t2g and Eg. We have 7 electrons. So therefore, we can fill it up this way: 1, 2, 3, 4, 5, 6, 7. So t2g 5, Eg 2. Therefore, we shouldn't consider this, because we have odd number of electrons in t2g orbitals. How about the next one? In the next one, cobalt is in 3 plus oxidation state. In total, we have 24 electrons. Therefore, now the electronic configuration is argon and then 3d6. But the difference now is we have to consider water as a strong field ligand. So therefore, the Eg will be empty. Everything will be paired up in T2G. Therefore, T2G 6, Eg 0. We have even number of electrons. Therefore, we have to consider this one. So this is yes, this is no, this is yes. For the next one, we have copper. Copper, when it is neutral, the electronic configuration is argon and then 4s1 3d10, not 4s2 3d9, because half filled and completely filled d orbitals are more stable due to higher amount of exchange energy. Therefore, we have to write the electronic configuration this way. But when it is copper 2 plus, we have 27 electrons. So therefore, 1 electron from 4s1 should be removed and 1 electron from 3d10 should be removed. Therefore, now the electronic configuration is argon and then 3d9. In presence of ligands, this would split into T2g and Eg. We have 9 electrons in total. Therefore, 1, 2, 3, 4, 5, 6, 7, 8, 9. T2g 6, Eg 3. We have even number of electrons in T2g. Therefore, we have to consider this. And then for chromium, atomic number is 24. When it is neutral, the electronic configuration is argon and then 4s1 3d5. But here it is mentioned as 3 plus. So therefore, now we have how many electrons? We have 21 electrons for chromium 3 plus. Therefore, the electronic configuration now is argon and then 3d3. In presence of ligands, this would split into T2g and Eg. So 1, 2, 3. T2g 3, Eg 0. That means we are not considering this. This means 3 complexes have even number of electrons in T2g orbitals. This means option 2 is correct.